Sorry.
Oh, you're recording.
So you can listen to these on Blackboard.
I watched them.
Okay, our essential question is what sets apart a function from a relation? A relation is just any set of ordered pairs. Yes, it is 29. Examples of relations are just all of these sets. And remember, these squiggly lines represent a set. So this is a set of the ordered pair, negative 10, 1, 55, 2, and negative 23, negative 5. So it's just a set of ordered pairs. A function is a special type of relation where each x value has only one y value. So our x values don't repeat. Every single function is a relation, but not all relations are functions. Relations are just sets of ordered pairs. Functions are specifically sets of ordered pairs that have all unique x values. We can represent relations in 4 different ways. We can have a set of ordered pairs, so just a list. A mapping, which is what's shown down here, and we'll explain those. A table, like the x and y value table that you probably saw last year, and a graph, which is what you saw in your warm-up. So, our first option is a set of ordered pairs. If I want to know if this is a function, then I'm looking to make sure none of the x values repeat. So number 1, we have negative 1, negative 4, 1, and 8 as x values. Is that a function? Yes, because none of those values repeat. Negative 1, negative 4, 1, and 8, those are all different numbers. All right, number 2 is 3, 13, 3, 8. Is that a function? No, because this x value repeats. And what about number 3? We have 1, 4, 6, 0, negative 5. That's a function. You might have noticed that all of the y values repeat. That's okay. So it doesn't matter what the y values are. As long as the x values don't repeat, then it's a function. So in number 3, all of the y's values repeated. That's okay, as long as the x values are not repeating. Yeah. All you have to do is make sure x values don't repeat. These are mappings. In mappings, the left bubble is always the x, the right bubble is always the y. I could represent this mapping as a set of ordered pairs. It would be 0, 1, because the 0 and 1 have an arrow. 3, 2, because the 3 and the 2 have an arrow. 6, 3, and 6, 4. Is this a function? No, because the... Good, the 6 is repeating. Okay, next one. 1, 6, 3, 6, 5, 6. Is that a function?
Yes.
And 6, negative 2, 2, 6, and 0, negative 2.
I don't understand.
Yes. You don't get this one? Okay. So this 6 has an arrow going to negative 2. That's your ordered pair. This 2 has an arrow going to 6. That's an ordered pair. This 0 has an arrow going to negative 2. That's an ordered pair. So our x values are 6, 2, and 0. None of those numbers repeat. That makes it a function. Same thing for this one. Our ordered pairs are 1, 6, 3, 6, and 5, 6, because those are where all the arrows go. Our x values are 1, 3, and 5. This one's a function because the x values don't repeat. This first one was 6, 3, and 6, 4. So we had repeating x values. That made it not a function. Okay, on the back, in a table, our x values here are negative 1, 2, and 5. Is that a function?
Yes.
The next one is 3, negative 8, 5, and 3.
No.
No, because this 3 repeats. You gotta be careful. And the last one is 2, 2, and 2. Is that a function? Okay, the last way to represent a relation is a graph. Since we don't have a set of ordered pairs, we're going to do a vertical line test. So, if on your graph you can draw a vertical line that's a straight up and down line, and it will touch the graph more than one time, then it is not a function, because that's where the x values would repeat. So this first one, here's my vertical line, here's my function, it touches it once there. If I keep moving it along, my graph would touch a vertical line 3 times here. 1, 2, 3. So this is not a function, because somewhere on this graph it touched a vertical line more than once. So this one's not a function.
I get it.
Okay. We'll keep going.
That's not a function.
Okay, this one, if I took this blue vertical line and I moved along the x-axis, it's touching my blue paper one time the whole way, and now it's going to go back up, and it's going to keep touching it one time. So this is a function, because it only ever touches the blue line once. I can't draw a vertical line anywhere where this pink line would cross that twice.
Is this like symmetry or something?
Kind of.
So how would you know which line to use?
Okay, so right here I'm going to trace my function. It's pink. Or my relation. Okay? This is pink. I'm going to see if I can draw a vertical line anywhere on this graph where it would touch it twice. So if I drew a vertical line right here, it touches my vertical line at the top and the bottom. So vertical line will go through these 2 points. That makes it not a function. And this one's nice because it has lines so we can see. This point is negative 3, 3, and this point is negative 3, negative 3. So my x value up top is negative 3, and this x value is at the bottom is negative 3. So the negative 3 repeats itself, which means that's not a function.
Wait, can you explain why number 2 isn't?
Why this one is a function? Because there is no one place that I can draw a vertical line that would touch my line more than once. So like here's a vertical line, it touches it one time. Here's a vertical line, it touches it one time.
Other lines are part of it.
Oh, no, those are the axes.
Oh.
Okay, this line, is this a function? Yes, this is called a linear function. It's a straight line.
Wait, so if it has a straight line, it's a function?
Well, these are straight lines, but they go back over itself. So this is not a function. Yeah, if it crosses over each other, it will not be a function.
So that's not a function?
This one is, this one's not. This one is not, this one is.
How come that's not? How come that's not?
This one? Okay, if I took my vertical line, I want to see if this pink line ever touches this blue line more than one time at once. So every time I draw it, it is not touching at all. Or it's only touching one time, not twice. So this pink line only intersects the blue line at one spot, every vertical line.
Oh, number 5 is just dots.
Okay, this one are just dots. So,
Connect the dots.
don't connect the dots. Here's a straight line through the first dot, it doesn't touch any other. Here's a straight line through the second dot, it doesn't touch any other. Here's a straight line through the next dot, it's not touching any other dots, not touching any other dots, and not touching any other dots. So this is a function because all of those dots only fall on the one unique vertical line. Alright, last one, is this a function? No, because if I draw a vertical line, it will touch it more than one time. And last one. If I try and draw a vertical line through one of these points, it hits both of them. So these 2 points are on the same vertical line. This is not a function
What's that?
because of right here.
What's that circle?
What circle? I was circling all the functions. Okay, you guys write a short summary and explain to me how you know if something is a function.
Wait, from just graph?
Any of them, all of them.
Just in general functions? No,
Yeah, if you're looking at something, how are you going to know if it's a function or not?